let us try to understand how to use a convolution neural network. So already we have some theoretical knowledge on convolution neural network, that is CNN. So based upon that, we will try to understand like how to write code or how to use Python with CNN. And let us try to understand that now, right? So for that, I'm importing all the packages now. From keras.models, import sequential. From keras, import optimizers. From keras.layers, import dense, activation, flatten, convolution 2D, max pooling 2D, average pooling 2D, global max pooling 2D, zero padding 2D, input. Keras.models, import model. Keras.preprocessing, import image. So I'm importing all the packages now. We know what are optimizers and what are the functions of dense, activation, flatten, convolution, max pooling, average pooling, and what is padding, what is global max pooling, right? So we have a clear understanding on that. So just I am loading an image now. Image.load underscore image. So basically I'm taking a flower of image of a flower, right? So now what I'm doing is like I'm converting it into an array. Let me look at the shape of the image now. It is saying that 350, 700, 3. So this 3 corresponds to RGB, right? So the channels basically. So 350, 700, 350, 700, right? So hope it is clear now. So now the input or the image is ready. Let us understand padding first. When we talk about padding, two types of padding options. So the first one is valid. Valid means no padding. Drop rightmost columns and bottommost rows. Same means padding size is equal to k by 2, where kernel size is equal to k, right? So customized paddings can be given with 0 paddings on the layer, right? So let us understand now. So what I'm doing now, I'm writing padding is equal to valid now, right? So model is equal to sequential. I'm using sequential model and then adding convolution 2D and input shape is 6, 6, 3. So this is the shape of the convolution kernel and filters is equal to, this is the input shape 6, 6, 3 and the number of filters is equal to 10 and the kernel size is 3, 3 and strides what I'm using is 1, 1 and padding is valid and I'm trying to get the output shape of this, right? So model dot output underscore shape, right? So what will happen now? So we had this input as 6 minus kernel is 3 plus 1, right? So this is the formula n minus f plus 1, right? So this is what we have seen before. So 6 minus 3 is 3, 3 plus 1 is 4, right? So that is what we are getting over here, 4, 4. And what is this 10? And this 10 is nothing but the number of filters, right? So the first part is done now. Now, if the padding is the same, so what is happening now? Model is equal to sequential and again model dot add convolution 2D, input shape is 10, 10, 3 and filters is equal to 10 and kernel size is the same, striding is the same and padding also I am using it as same, right? So that is done now. So what do we get now? Output as 10, 10, 10, right? So what we have made the change over here, we have done padding is equal to same, right? So padding is equal to same, that is what we have used, right? Actually, like how we can understand is like if it is valid, there will be no zero padding outside the edges. And when we talk about, say, say for example, I can give you an example so that you can connect with that and try to understand. Say for example, I have an input image x is equal to 2 comma 3, and I'm using valid pad now, right? So the maximum pool with 2 cross 2 kernel and stride 2 and valid padding, and the same padding means what will happen, maximum pool with 2 cross 2 kernel and again stride 2 and same padding. Okay, so what will happen now is like this, when you take valid padding, it will return it as 1 comma 1, but when you take same pad, it will return as 2 comma 4, right? So then after that, like in case if you want to apply clear image, you can do that, right? So basically valid means without padding, and if it is same with a zero padding, right? Hope it is clear to you. So that is why we are getting it as 10 comma 10 comma 10, right? So now let us do this user customized padding. So here input layer is equal to input shape is 10 comma 10 comma 3, and the padding layer we are giving now 0 padding. Padding is equal to 1 comma 1 input underscore layer, and the model inputs is input layer and output is the padding layer. But when you get the output, we are getting it as 12 comma 12 comma 3, right? So this is about the padding. So we have seen one thing about valid, and another one is about the same, and the third one is about the customized padding. So now let us study about filter or kernel. So number of filters can be designated, and the number of filters is equal to depth of the next layer, right? So when you write model is equal to sequential, and when you add convolution, this is the input shape, and the number of filters, kernel size, stride, and again we are using padding. So what do we get now? 10, 10, 10, right? At the same time, if you use padding is equal to the same, then you get the output as 10, 10, 20, right? Fine. Because we have used this one, right? Filter size as 20. So we are getting 10, 10, 20. Clear? So pooling. Maximum pooling is applied for rectangular region, and pooling size, padding type, and strides can be set similar to convolution layer. So again, a model is equal to sequential, and I'm adding convolution, input shape, filters, kernel size, stride, and padding. And we are getting the shape now, that is 10, 10, 10. Now when stride parameter is not defined, then strides will be equal to the pool size, right? Now what I'm saying, like here, if the stride parameter is not defined, then stride will be equal to the pool size, right? So now what do we get the output as? 5 comma 5 comma 10, right? So now I'm adding sequential now, and input shape, filters, kernel size, stride, and padding equal to same. And similarly, I'm using max pooling now, and then stride, pool size, and padding is equal to valid. And when you get the output, this is 9, 9, 10, right? And if you try with the convolution, 10, 10, 3, and filters is 10, kernel size is this, stride is this, padding is equal to same. And if you use average pooling, what is the output? 5 comma 5 comma 10. See, if you compare these two, here we have used maximum pooling, but here we have used average pooling, right? Okay. So now let us try to understand global max pooling. So here model is equal to sequential, and again these parameters are the same, and padding is given as same. And when you give global max pooling and the number of filters is 10, the values are returned as a result of global max pooling. So you will get the output as none comma 10, right? So in case if we have to connect it to a fully connected layer, then convolution and pooling layers should be flattened, right? So what is the resulting shape now? number of instances, comma, width into height into depth, right? So model is equal to sequential, input shape, and filters, kernel size, stride, and padding is equal to same. Now, what do we get the output as? Model dot output underscore shape is 10, 10, 10. When you flatten it, what will happen now? You'll be getting it like a number of instances, comma, width into height into depth, right? When you flatten it, that is why you are getting it like 10 into 10 into 10, which is equal to 1000. So now the fully connected dense. So after flattening the layer, fully connected layer can be added. So the output shape should be designated. Now the sequential, adding convolution, filters, kernel size, strides, and padding. Padding is given as same now, and this is being flattened, and the dense is given as 50, right? So now when you get the output, the number of nodes, this is what we have seen, right? So we are getting it as 50. So this is just the basic to understand the convolution neural network. We will also try to understand how we get these outputs basically, right?